Hello students, welcome to Saurabh Sir classes. Today in this video we will discuss on CSIR UGC NET GRF examinations question to how to solve the questions, and this is a continuation to our previous video and where we have already discussed some of the questions of this exam, CSR UGC NET GRF exam. Now our first question is for number one, for mono ionic complex UO2 NO3 whole 3, the correct coordination number, the correct coordination number and geometry respectively are A 8 and hexagonal B 5 and square pyramidal, 5 and square pyramidal, C 8 and anti 8 and anti prism, and D 5 and trigonal bipyramid, trigonal bipyramid. Now the question is that for coordination complex UO2 NO3 whole 3, the correct coordination number and geometry respectively are 8 and hexagonal, 5 and square pyramidal, 8 and anti-prism, and 5 and trigonal bipyramid. Now actually the structure of this complex is U So total coordinated bond is now the coordination number is coordination number, here it is 8, and it is a and the geometry of this complex is hexagonal bipyramid. So the correct option is A. A is the correct option. So this is the structure of this compound. Actually there is one oxygen also. This can be also written as, we can draw it like this. Now so there is this is the structure of this complex, and we have this as 8, coordination number is 8, and geometry is hexagonal bipyramid. Now our next question is number 2, Csir effect is option A, predominantly due to enthalpy change. B, predominantly due to entropy change. C, independent of ring size. And D, due to equal contribution of entropy and enthalpy. Equal contribution of entropy and enthalpy. Enthalpy change. Now, once again I am repeating the question. Csir effect is predominantly due to the enthalpy change, predominantly directly due to enthalpy entropy change independent of ring size due to equal contribution of entropy and enthalpy. Now, in this case, we see that this from the thermodynamic point of view, we see that during the entropy, the number of species is increasing. So it is entirely a function of the entropy, and Gillette effect increases the entropy of the system as the number of species is increasing. So we find that in this case CO NH3 whole 6 3 plus 3 En is ethylene diamine. This gives us CO En whole 3 plus 6 NH3. So here after the reactivation, number of ammonia molecule is increasing, so entropy is increasing. Now ethylene diamine is a bidentate ligand. This is ethylene diamine. It is a bidentate ligand, and this ligand can attack metal and occupy the two coordination position. So 3 ethylene diamine molecule, this is En, so it will cover up all the 6 coordination position, and 6 ammonia is coming out of the complex. So the chelation is like this way: CO En and En. So in this way, this chelation is occurring, and these 6 ammonia molecule, as the number of molecules is increasing, so entropy is increasing, and delta H of the reaction remain almost same. So there is no significant change in the enthalpy, only entropy is changing. So option B is correct. So predominantly due to chelation, entropy is increasing, and for a spontaneous system to occur, then this entropy must be positive. So as the entropy is increasing, this is a favorable process. Our next question is number 3. If the rate of reaction if the rates of reaction are R1 and R2 at concentration C1 and C2 of a reactant respectively. The order of reaction, the order of reaction in assuming that the concentration of all other reactants and T remain constant. T is the temperature, remain constant. Remain constant with respect to reactant given by A n equal to log of R1 minus log of R2 by log of C1 minus log of C2. B n equal to log of C1 minus log of C2 by log of R1 minus log of R2. C log n equal to log of C1 minus log of R1 by log of C2 minus log of R2. And D log of n equal to log of C2 minus log of R2 by log of C1 minus log of R1. So we have to find out the actual relation. Now it is given that if the rates of reaction are R1 and R2 at concentration C1 and C2 of a reactant respectively, the order of reaction N, assuming that the concentration of all other reactants and T remain constant with respect to reactant given by the order of reaction N with respect to reactant given by log R1 minus log R2 by log C1 minus log C2, log C1 minus log C2 by log R1 minus log R2, log C1 minus log R1 by log C2 minus log R2, log C2 minus log R2 by log C1 minus log R1. So all these we have to find out the correct relation. Now for R1 we will have K into C1 to the power n, where K is the specific reaction rate constant. K is the specific reaction rate constant. Similarly, R2 will be equal to some constant into C2 to the power n. So from here we are getting R1 by R2, that is equal to C1 by C2 to the power n. Now taking log in both sides, we get or log of R1 by R2 equal to n log of C1 by C2. Hence n equal to log R1 minus R2 log R2 by log C1 minus log C2. So this is the correct relation. So we are just taking this n equal to this by this, and this is log R1 minus log R2, and this is log C1 minus log C2. So n equal to this relation comes. So our correct option is A. A is the correct option. So we know from this rate of reaction that R1 equal to some constant into C1 to the power n, as the rate of reaction is given, order is given as n, and R2 equal to some constant into C2 to the power n, and dividing R1 by R2 we are getting this formula. So here n equal to this one. So this is the relation, and with this we are finishing today, and all these questions I hope you have understand it and the logic behind all these questions, and thank you for viewing these videos.